we're going to build this LED circuit. We've got the anode as the long leg, the cathode is the short leg, and we're going to go ahead and put that into the breadboard. And then we're going to take a resistor and we're going to go from the short leg over to ground. So that's our blue ground rail. And we'll bend these, make sure they don't cross. Let's see if we can get a little closer there. So we're going from here at row 28. We've got the resistor jumping across to the ground power rail. So we need to attach that blue now to a ground pin. So I think we're in 12. There we go. Now we've got ground going across to this blue power rail, into the resistor, into the anode leg of the LED. And then let's pull this back out again and test that our bulb is working. So if we go from row 25 here, we'll go ahead and touch a power pin. So at the 5-volt power pin, we can see that turns on the LED. So the bulb is working, the resistor is working, and our jumper cables are working. Now to control this with the Raspberry Pi, using the RPi.GPIO library in Python, we're going to need to pick a pin. So let's go ahead and put this in GPIO pin 25. But you could use any of these available pins, 18, 13, any of those that are open. So we've got GPIO pin 25 to control the LED. So now we'll go ahead up to the code. Okay, so I opened up Thani, and we're going to start by saving this. We'll give it a name. So let's call this green blink.py. Okay. And we'll write some code now to make our green LED blink. So in our lessons before, we were using the GPIO 0 library in Python. Now we're going to use the RPi.GPIO library. And we'll go ahead and import that as GPIO. The as just means anytime I reference that library, its functions in my code, I can use GPIO at the beginning to shorten it. So let's see, we're going to also need to import the sleep function, and we really only need sleep from the time library. So from time, we'll import sleep. Okay, and now we're going to call that GPIO library and use the set mode function. Oops, GPIO dot. And we're going to do the BCM as the pin. Okay, the BCM on your pin map, that stands for Broadcom SoC channel. Those are the numbers on your actual extension board. If you're using the broad pin numbering, you just type in Google search, do Raspberry Pi pin map, and then in the column that says P1, those would be your board pin numbers. The column that says BCM, those are the pin numbers that you would use for BCM. Okay, next we're going to do GPIO.setWarnings method. And we're going to set that to false. That'll prevent us from getting any error messages from conflicting programs. And then GPIO.setup, and we're going to set up an output channel for this LED. So we'll start by putting in the pin number, which we put our pin in 25 on the breadboard. and then GPIO.out will assign that channel as an output channel. So we can send information to pin number 25 as an output. We just can't receive information back. If we wanted to do an input channel, say instead of an LED, we were using a button to control something, then we would be doing GPIO.in. That would be an input channel, so we could get information from the button into the Raspberry Pi. But an LED either is on or off, so that's an output. So we'll do GPIO.out for the LED. Okay, next we're gonna create a loop. So while true, we want the following things to happen. We're gonna start by, GPIO, there we go, dot output, because it's an out channel. The pin number is 25, and then we're gonna set its status to high. So 25 is the pin, GPIO high, that sends 3.3 volts of power into that pin. That should light up our LED. Then if we do GPIO output 25, then GPIO low, okay, that would turn off the LED. But this is going to happen so quickly that it's going to look like the LED is constantly on if it's flickering on and off super quickly. So in between high and low, we're going to use that sleep function that we imported from the time library and sleep for a couple seconds. So same thing, after we turn the power off, we're going to let it sleep for a couple seconds. So it's going to blink on, blink off, then loop again, blink on, blink off, loop again, blink on, blink off. Okay, so let's go ahead and run that. And then we'll look down at our circuit. And there it blinks on, and then off again. So we know it's working.